I'm Phil Baljeu. It's going to be about my sort of progress through oscillographics and sort of the not really lessons I've learned, but there's little things in there, and my ethos, I guess. So I first want to talk about the Oscilloscope Graphic Artist by Mitchell Waite, which is kind of like the it's sort of like the beginning of it for me. It was the like genre-defining song. Like Black Sabbath's Black Sabbath song is like the definition of doom metal. It's got like the heavy riffs and the drums and lyrics about Satan and stuff. The Oscilloscope Graphic Artist has all the components of like oscillographics for me. It has a time-based oscillator, which synchronizes all of the oscillators. Then there's a couple of shape oscillators. There's a high-frequency oscillator that adds sort of form to the shapes, texture, like a shell around the shapes. Four-quadrant multiplier, which is actually really a shitty four-quadrant multiplier in it. It's just like a FET switching inverting. So it's not great, but there's phase shifters and a mixer. So all those things are kind of like the basic ingredients for oscillographics. So how I started in electronics was I started building like noise synths and stuff. This is a couple of them there from like a decade ago or something. But I started when I was like 15 years old because I couldn't afford synthesizers. Like a teenager, no money. So I just started learning how to circuit bend and stuff. And then I built simple oscillator circuits and stuff. That's how I got into it. And then I started making these kind of little drone synths and stuff based on like CMOS chips, which are logic chips from the like 70s. They're really cheap. They're everywhere because they were used in computers and stuff like that, and electronics. They're kind of just like digital glue logic stuff. So then I moved on to a VGA synth, and that's how, I guess Chris King, he posted about me because I had on the Electro Music Forum. I just posted about what I was working on. It was this like plexiglass panel that I drilled with banana jacks, and it was all these CMOS circuits that I sort of cobbled together because I found out about video synthesizers and I wanted to try and build one. But I didn't know, anything about video. I didn't know that there's like sync pulses for lines and frames. I didn't know what ramps were. I didn't know any of that stuff. But in a magazine, I found, like on the Internet Archive or something, I found a Pong article, like how to build your own Pong at home. So it was from the 70s when Pong was popular, because it's not now. But it had a sync generator in it, but it was monochrome because it was just like sync. There was no color burst or anything. So that's what I started with, and then that didn't really work for what I wanted to do. And then I found out that VGA is just a bunch of analog color signals, RGB, and sync. So I put those in there and put the colors in. I tried designing my own sync generator, but I was really not smart about it. So my aspect ratio was 1:1, so it was just a square, not like a 4:3 or anything. But it worked. I had to crop it. So those pictures on the side there are some of the output of it. It was really rudimentary. It was just a lot of squares, basically. But it, got me into it. Not that. Can I go back? Yes. Nope. So around this time, one of the things I want to emphasize with, I guess, this talk, which is like a loose, improvised kind of thing, but is sharing and how important sharing schematics is and circuit ideas and concepts and just that whole, like, Dan Sandine had this thing. He was a video artist in the 70s, and he made a synthesizer called the Sandine Image Processor, but he open sourced his whole document to build the synthesizer so that people would be able to build it themselves, and he thought it was a better way of distributing the synthesizer than trying to sell it. So I guess this whole thing is going to be wrapped around that. But around this time, I contacted Richard Monkhouse, who had designed a video synthesizer for EMS. And he sent me the whole service manual for the Spectre. And so that's when I started getting more ideas of the concepts of a video synthesizer, which was like ramps and shape generators and how you compare those ramps to make shapes on the raster and stuff. But it was a lot of CMOS circuits and stuff like that in there too. So it kind of, this was trying to be kind of like my version of a Spectre, but it was a piece of shit, really. It was like a bunch of rat's nests behind the panel of just circuit boards lying everywhere, and I think I used Cat5 cable because I didn't have any other kind of cable. I can just walk to the dollar store and get like a Cat5 cable and rip out 8 wires from that. Don't do that. That wire is shit. So then, after the sort of, I guess that's raster synthesis, I began in oscillographics, which on the left there is the oscilloscope graphic artist that I didn't build, but I traded it. So I gave my friend a phaser pedal, and he gave me his incomplete build of the oscilloscope graphic artist. And it was in that Hammond case. But that's when I started really, like, getting into it. Like, I had a box, I could do it now. And I modified it to have some zoom functions, frequency range shifting and stuff to make these shapes. So then on the other side, it was another project box. It was like I had just discovered amplitude modulation, so Z modulation of signals to kind of, you could have a static form, but then animate those forms with light. And then, so the one to the left there, I took a circuit block out of the oscilloscope graphic artist and made 4-quadrant multipliers, which are, if you're not familiar with them, I guess, it's, you can sort of flip the image back and forth using a 4-quadrant multiplier. It inverts a signal and uninverts it, or reinverts it. And then the one to the right of that is an oscilloscope, Spywriter by Elector, which is also a project from a magazine like the Oscilloscope Graphic Artist, but it made more spiral shapes, and I have that on the screen. I'll bring that up. So it does like these sort of spirograph shapes. So like that's a very static image. It's not particularly interesting. So when I said Z modulation, let me see. I'm gonna try and get something going here. Yeah, so you can. That's Z modulation. You kind of morph the shape while it's still being static, but it adds some sort of life to it. So on the, I don't know if you can read it, but it says phaser on the Dymo label. And that's when I started sort of really realizing the power of a phaser, which it can take, you can have a single waveform and you can phase split it and sort of expand that waveform into a full shape. Because I'll try and patch that up. Now introducing dog. So without any sort of phase modulation or phase shifting, it's just you get like the same signal to X and Y, you just get a diagonal line. But so that's like a sine wave that has a decaying amplitude, but it makes a spiral when you have phase shifting. So, you know, that I realized was pretty powerful. You know, you could morph the shape pretty easily using just one signal source. You don't need a stereo thing or anything. It sort of splits it into stereo. So then I built this into a microphone case. because I guess this whole thing is also glued together by the fact that I'm really broke all the time. So I found a microphone case like behind a music store, and that panel is a street sign. I don't know what kind of street sign, a yield street sign maybe. But so I started building like all the sort of blocks from the oscilloscope graphic artist. I was copying them and ripping them out and putting them into this modular system. So there's oscillators there that are from the oscilloscope graphic artist. There's a phase shifter, which is like a phaser pedal. There's filters and mixers and stuff. So I was trying to take all the ingredients of the oscilloscope graphic artist and sort of expand it and blow it up into something more expressive. After that, I kind of shifted focus completely to designing the LZX Castle stuff, which took a long time, and I didn't really know what I was doing at first. I kind of wanted to do a glitch series, because I don't know if you're familiar with the LZX stuff. It's really precise, and it does what it should do. It's if it's a sine, it's a sine, and if it's a square, it's a square. There's no sort of non-linearities or irregularities to it. So that's I kind of wanted to try doing that, but I didn't have a focus. And then eventually Lars of LZX suggested that I do logic stuff. So that tied back to the Spectre and my original VGA synth, which was the plexiglass thing. So I started to realize what I had tried to do several years before with this series for LZX. And this is all like sort of, I guess, mid-70s computer stuff. So there's like a analog to digital converter, a digital to analog converter, so you can get things in and get things out. There's clocks and there's shift registers and counters and stuff. So all this stuff, to make really primitive computer-ish images. So I, shifted all away from oscillographics and really dove into that. But after the Castle series, I got really bored and kind of wanted to do something, and I revisited the oscilloscope graphic artist project. It was around Christmas last year, I think. And I was really getting frustrated that people weren't sharing their techniques and weren't sharing their schematics and stuff, and there was not a lot of projects for people to build for oscillographics. So I took the oscilloscope graphic artist and made a schematic, and then I made a circuit board, and then I just, like the same day, I just posted a zip file on video circuits for the Gerber files, which are the files for the circuit board, so you can get them manufactured. Like Seed Studio, you can upload the Gerber files, pay $6, and you'll get 10 PCBs, and you can get them shipped. Shipping is more expensive; it's like $30. But so people could order this board, build a project that has really cheap components. It's all audio, kind of general purpose components. So you spend like $20, and you can build a full voice of an oscilloscope graphics setup. So I posted that online and did that project. It's in my case, but it's synchronized to my LZX, so it doesn't look the same. So I did that, and so then I moved on to this Spywriter project, which kind of can do spirographic things, and this is going to be my next sort of community offering, I guess, because like I said, sharing is super important so that people have tools to make the art that they want to make, and then have the schematics so you can see what's happening inside of it and you can modify it. And it's really important, I think, to have complete functional blocks that people can learn from and understand and grab things and duplicate them into other projects. So I contacted Mitchell Waite, the guy who made the oscilloscope graphic artist, and I talked to him, and he doesn't care about the weird stuff he did in the 70s, which I thought was interesting. He got really famous, I guess, for making books about like home computers in the mid 70s when that stuff wasn't popular. You know, he was in the what was the club in California? The computer club? Does anyone know? Yeah, the one that Apple came to. But he was a part of that, and he was there when, you know, Steve Jobs and Steve Wozniak brought the Apple I in to show it off. But he got really famous by making a bunch of technical manuals and like how-tos and beginner's guides to computers and stuff. So he was, you know, this sort of broke college student trying to make money, and he would submit articles to magazines about weird novel stuff, and one of them was the oscilloscope graphic artist. But he couldn't really make money on that, so he went to computers and then got famous with that and kind of threw away all this past with the oscilloscope stuff and all the weird sort of things he did with that. So he wrote a book that had all these weird projects in it, like Kirlian camera and brainwave synchronizers, and one of the things was called the synth shape, and it's basically like an upgraded version of the oscilloscope graphic artist. So originally when I contacted him was to find out if I could reproduce that and make projects out of that for people, put the Gerbers online and have people do that. And he was just like, yep, do whatever you want with that stuff, I don't care. So I started working on that, and I started to realize that it's very important to have standardized circuits, to have, you know, functional blocks that can work outside of the closed system. So I tried to, you know, make the synth shape VCO, and it doesn't lock very well. It doesn't synchronize very well. So it's not great. There's some weird old esoteric parts in it, like there's some complicated dual gang pots that have weird values. So it's difficult to sort of update those things, and it wasn't very it wasn't a very good project for people to kind of pick up and do, because you needed to source all these weird things. So, you know, that's when I realized that it's important to have very common stuff that you need to bring in, common components, pots, and so, like I said, I haven't done this before, so I have no real ending. I'm going to ask questions, or have people ask questions, if there is any. Yeah, so this was a project out of a German magazine, Elector. It was called the Spywriter, and it was, you know, a very simple project that has a few audio op amps in it and a synchronization oscillator, which, you know, like the oscilloscope graphic artist, it has a synchronizing pulse. But it can do these sort of spirograph figures very easily. Like there's only 6 controls on here. There's CV. Yeah, there's CV in it. So I need to boost that CV actually. Yeah, so there's CV on it, and it can do a lot of stuff. It all kind of looks like this, but, you know, if you keep exploring. That's the sync pulse. You would blank that out, and there is a blanking on it, but I just didn't plug it in. I didn't think anyone would notice. So now it's kind of overblown, but yeah, it's blanked now. You happy? I'm trying to mix it so it's not so bright. Yeah. So now there's still that thread that kind of, oh, the frame rate is really low. Yeah, there's still that thread, but that really bright line is gone. And I actually wanted to ask a question to Andrew Duff. Why is he still here? Hey. Do you use a sync pulse? Do you synchronize? Okay.
When there's ever any talk about blanking, my mind goes blank.
Mm.
I've never applied it to anything, so I've never got it as a thing.
Okay. Mm-hmm.
So I'm sitting here like, oh yeah, Derek's asking me a question.
Yeah. Well, it's blanking in sync, because you didn't mention that, and because that's what I find is really important about the oscilloscope graphic artist, and like I said, the genre, I guess, of the oscilloscope graphic artist is that it has a time-based oscillator that everything follows. But it's interesting to see everyone's approach, how they all differ.
Can you explain why sync is important in a system like this?
I can try.
You can.
So, like on a television screen, on a raster, there's a frame rate and there's a line rate. And that needs to be all, the line rate has to be synchronized to the frame rate so that the picture is stable, so that it's repeatable constantly. With oscillographics, it's the same thing, but it's much like a frame rate. It's around like 60 hertz. So that stuff happens, but then it's reset back to that point, back to that 60 hertz, so that when you display it like this, it looks like a static form. Like it's kind of, it's wiggling because it's analog, but it's mostly stable, and that's what sync does.
Can you remove the sync and show what it looks like?
I can.
Can you remove the sync, please?
Sure.
Show us without the sync.
It'll look like shit. It's blanked, so I need to get rid of blanking. It's a circle. Because there's nothing making it create these interlocking like beat frequencies. It's just free running signals.
And can you change sync frequency to slow it down?
On this?
Yeah.
This one, yes.
I'm just curious how it looks. I mean,
yeah, you can synchronize it to like an LZX signal, or you can video signals, or you can synchronize it to a 200 hertz oscillator and change that frequency if you wanted to.
Yeah. I'm curious, like when you slow down the sync, does the drawing itself slow? Does it take then for example, if it would be 1 hertz, would it take 1 second to draw entire?
No.
Or it would just draw one quick image once.
The time constant of the oscillators is like a certain frequency range. Yeah. So if you slowed down the whole thing, it wouldn't slow down the whole drawing. It would just
okay.
It would ring faster, and it would look more detailed to a certain point.
Mm-hmm.
But then it would sort of collapse and not doing anything.
Okay.
The master frequency, the master clock, it's a fixed frequency, isn't it?
Yeah. So normally you'd want sync to be fixed, because if you're going to film the output, you'd want it to be stable. So you'd set your camera frame rate to, if you've ever pointed your camera at a television and seen it flicker and create bars, it's because your camera is taking a different sync rate than what the television sync rate is. So you want to have those matched and constant so that you don't ever get flickering, you don't ever get any sort of artifacts that are undesirable. But it can be variable, but then you start getting the flickering and stuff if you're filming it. If you're watching it, you normally don't see it. Yeah.
How similar are the circuits between the Electro circuit and the weight circuits? Because the weight circuits, both of them are really quite the same, actually. One's just a bit fancier than the other.
Yeah, right. Yeah, so the synth shape and the oscilloscope graphic cards are really similar, but the Electro one is completely different. The only thing that they share is sync, that there's a master clock, but this one is a bunch of dampened sines, 2 dampened sines. So it's like you impulse something, a filter, and it rings a little bit. It has a sort of dampening quality. It does a sine wave. And it's 2 of those together to make the XY, and the frequency relationships between them make the sort of the spiral shapes like that. And so what the dampening, how that relates to the image is that it gets closer to the middle as it decays.
So it's basically a bit like these harmonograph things where you have these weighted pendulums that are swinging at different ratios to each other.
Yeah, because that's the same thing. It's a sine wave and it's naturally decaying. It's an analog of that stuff.
So, Philip.
Yes.
I'd like to ask you a few questions.
Go on.
Will you please show us the OGA?
Yeah, I'm bad at improvising words. Okay at improvising music.
Take your time. It's okay. We'll wait.
So the OGA is going to look a little weird because it's being synchronized to the LZX. And I'll try and get something that doesn't look like scribbles. I mean, I think it's being synchronized to the LZX. Who knows? So you put me on the spot, so I'm trying to like make a cool shape.
That looks good, Phil.
Yeah, hold on, I'll get
So,
something.
Philip, this project you delivered it online as a freely available downloadable package, so people can get their own PCBs printed, and they don't need to know very much to kind of produce it, but they can kind of go out and build this for themselves. And you're running a workshop to build these
Right.
as part of the festival.
There's
And
one here and one in the
one
city
in
name that
Ljubljana.
I'm not going to butcher.
Yeah. But it's a really good way to get started with oscillographics because it's super simple, right?
Yeah, exactly. Like
Yeah.
oscillographics is in this perfect spot between like proper video synthesis and audio synthesis, where video synthesis is very expensive because you need very expensive high specification parts like op amps and stuff. Audio is very general purpose. You don't need expensive parts. It's all generic, off the shelf. You can go to your local electronics store and probably find all the parts. So oscillographics doesn't need that high spec stuff. You can still make really nice images with just really basic components.
And it's really easy to find old oscilloscopes almost everywhere.
Yeah,
depending on
until Andrew Duff does some sort of tutorial about that too.
I guess I'm spoiled. I found my first 2 in the street. So
Yeah, they can be easy to come by, and like if they're about $100 or something on eBay. So that's a more the frame rate is shit, but that's a more interesting shape. You can see.
that's really pretty.
That's a very typical like oscilloscope artist shape.
Can you explain what's happening right now?
With that?
Yeah, is that possible? Or?
There's 2 triangle waves. So the hard edges that are there come from the triangle wave, the 2 triangle waves. That's probably better.
If you plugged these into speakers, you'd hear 2 tones.
Right.
So
yeah. Two really similar tones because stuff looks really nice when you have harmonics of the sync frequency.
Yeah.
So it sounds like a really kind of pulsating drone. There's no audio I can plug into, but Get ready for buzzing, I guess.
Yeah, this might be loud.
Is there volume control so that this doesn't?
What is that awful noise?
Yeah, that's not the oscilloscope artist. That's round. Don't know. It kind of sounds like that, anyways. Yeah, as a lot of people that work with oscillographics know, that it's not very pretty sounding.
I was kind of really asking that because it kind of demonstrates how simple what's going on is, but you generate these complex shapes.
Right,
and I
yeah.
think it's really nice that it's like this accessible thing,
Well,
which you were kind of talking about, this kind of package that people can go away and make their own work.
Yeah. I think someone is going to be doing a performance that is an oscilloscope graphic artist.
I wouldn't know anything about that.
Yeah. It's Chris King, by the way. He's going to be doing one.
Is that synced now? Is that synced to your
No. So,
That's not synced.
yeah, if you synchronize it, it stops moving.
Ah. I feel like I'm doing something wrong, seeing as you asked me whether I use sync or not.
Well, no, it's a
No,
valid way of doing it.
Yeah, that's. I made one of these and it doesn't seem to behave like your one.
Oh, you made one?
Yeah,
Oh.
I brought it with me, so I'm gonna.
The oscilloscope,
Get it to
like
fix
my version of it?
Yeah, yeah.
I failed. I don't know. Yeah, I don't know. Improvised talks. Thank you.
Thank you.
Thanks, Philip.